Good day. Welcome back to Lesson 5 on plasma proteins and ESR, or erythrocyte segmentation rate. I'm Dr. Penny Nansamba, a lecturer in the Department of Biomolecular Laboratory Technology and Molecular Biology, known as BLT, in College of COVAB of Veterinary Medicine, Animal Resources and Biosecurity, abbreviated as COVAB, in Makerere University. The content is part of the module BLT 2120, Hematology and Blood Transfusion Science. Welcome once again to Lesson 5, Plasma Proteins and ESR. This lesson is going to be divided into 3 parts. We've already done part 1, where we've looked at total plasma protein. So today we are going to look at part 2 of 5.2, where we're looking at fibrinogen. Our contents are going to include, number 1, an overview of fibrinogen, 2, rationale for the plasma fibrinogen tests, 3, measuring plasma fibrinogen. The learning objectives. By the end of this section, you'll be able to, number 1, justify measurement of plasma fibrinogen. Number 2, describe assays that detect and quantify plasma fibrinogen. Number 3, identify the underlying principles of operation for the assays. Let's start with learning objective 1. By the end of this section, you'll be able to justify the measurements of plasma fibrinogen. So, fibrinogen, why do we measure it? Fibrinogen is an important blood component because it's a clotting factor. We use its measurements to investigate bleeding disorders, such as the inability of clots to form, to investigate clotting disorders, where thrombi are forming in the blood, investigate disseminated intravascular coagulation, liver disease, cardiovascular disease, including cardiovascular surgery and recovery, inflammation, and we also measure fibrinogen as part of the follow-up on abnormal prothrombin time or abnormal activated partial prothrombin time. So let's go to learning objective 2 and 3. By the end of this section, you'll be able to describe methods that detect and quantify plasma fibrinogen, identifying the underlying principles of operation for the assays. The first assay we're going to look at is the clotable fibrinogen method, or the close method. The principle of operation. The active fibrinogen concentration is determined by the time taken for the patient sample to clot after adding a standard amount of thrombin. The method of measurements. Plasma is diluted to reduce interference from substances in the blood, such as heparin or the fibrin degradation products. Then an excess of thrombin is added. After this, the fibrinogen is converted into soluble fibrin, and we shall visualize a clot. The time taken for a visible clot to form is measured. We interpret the results. A shorter clotting time will actually mean that there's higher levels of fibrinogen in our sample. So when we get the clotting time, Reference values on a standard curve are used to interpret our test. So to derive the patient's fibrinogen concentration, using the charts shown on the left, we look for the clotting time, then draw a horizontal line from this clotting time to the y-axis, and we shall meet the curve. Then we shall draw a vertical line from the curve down to the x-axis, and the x-axis has got the fibrinogen in grams per deciliter, and that will be our value. The clotting time is inversely related to the fibrinogen concentration, meaning shorter clotting times indicate higher levels of fibrinogen. This method is quite accurate. Our second method is heat precipitation. The principle behind this method is that fibrinogen precipitates at 56 degrees to 86 degrees Celsius. So let's look at our method. We obtain 2 microhematocrit tubes, fill them with blood that's got anticoagulant, and centrifuge to get the blood to separate into the plasma and the blood cells. Now the first microhematocrit tube is used for measuring total plasma protein, and we saw this method in our previous section of 5.1, where we measured total proteins. Then the second hematocrit tube is incubated in a water bath at 56 to 58 degrees Celsius for 3 minutes. In this process, the fibrinogen will precipitate. The microhematocrit tube with the precipitated fibrinogen is recentrifuged and a reading taken from this tube. The difference between the two values, that is the one for total plasma protein and the tube that has been incubated and recentrifuged, gives us fibrinogen in grams per deciliter. An interpretation of this test: higher values may indicate inflammation. Other methods used to measure fibrinogen include electrophoresis and antigen assays like ELISA. So that brings us to an end on the methods used to measure fibrinogen. Let's have some self-reflection questions. Question 1. Heat precipitation method. Fibrinogen is determined by calculating the difference between what? Serum protein and albumin concentration, plasma protein and heated plasma protein, clot weight before and after heating, plasma albumin and globulin fractions. Our answer is going to be B. Plasma total protein and the heated plasma protein. Let's look at the second question. What is the primary principle of the Klaus fibrinogen assay? A. Measuring the fibrinogen antigen levels via immune assays, estimating fibrinogen levels from prothrombin time, measuring the thrombin clotting time of the fibrinogen depleted plasma sample with added thrombin, heat precipitation of fibrinogen from plasma. Your answer will be C. Measuring the thrombin clotting time of the fibrinogen heated depleted plasma sample with added thrombin. Let's look at a second question. This is the interface of a refractometer. The first one gave us total protein of 7.7 grams per deciliter. This was before heating. The second one gave us protein after heating, and it showed us a reading of 5.5 grams per deciliter. So our question is, what is the measurement for fibrinogen? So it will be the reading before subtracted, and you subtract the reading after heating from that. That gives us 1.5 grams per deciliter. In summary, the lessons we've learned on the rationale and basics of fibrinogen quantification include the justification, the different methods used, and the underlying principles of operation for the different assays. The next steps: refer to the lecture notes given to you on the study portal and the ETBTs and chapters in the textbooks recommended to you for further reading. These are a source of information. Thank you.